Today we're going to be learning about sequences. Sequences, we're going to learn how to describe and take sequences and extend them. We're also going to learn how to write an algebraic expression to represent a sequence of numbers. But first, before we get into any of this, we need to talk about what exactly we're talking about when we talk about a sequence. So let's start with some vocabulary. A sequence is a set of numbers that are in a specific order. In a sequence, we have terms, so each number in a sequence is called a term. And we have something called an arithmetic sequence, and that is where you have a numerical pattern that increases or decreases at a constant rate or value. Now, we've looked at these in the past, perhaps in elementary school, where we looked at number patterns and we just extended them. Today, we'll be coming up with algebraic expressions to help us extend them even further than perhaps the next three terms. But if I take a look at this sequence here that I just circled, we have 1, 2, 3, 4, 5 defined terms. However, we know the sequence goes on forever, so we know there's an infinite number of terms in this sequence. But if I'm just looking at the 5 terms that I have here, starting with the first term, which is 2, I notice that the pattern that is evident in this sequence is that I am increasing by a constant value. That's what makes it an arithmetic sequence. And in this particular case, the constant value that I increase by each time is 3. So I add 3 to get to each of the next numbers in the term. So that means that every number is based off, right now, just looking at it, based off the term before it. So if I keep going at this rate, I could come up with as many of the next terms as I would like, just figuring out the pattern. Now, to figure out the pattern, all I did was, well, I noticed that I'm increasing. 2 goes up to 5, 5 goes up to 8. And then if I think to myself, well, what's 5 minus 2? That's 3. Well, what's 8 minus 5? That's 3. 11 minus 8, that's 3. So I am indeed increasing by a constant rate. We typically like to think that if the pattern works for 1 and it works for 2, then it should work for the rest. So I always double check the first 3, and then you can eyeball the rest. All right, so let's take a look at an example. Describe the relationship between the terms in the arithmetic sequence, 7, 11, 15, and 19. Then write the next 3 terms. So we have our sequence here, which is 7, 11, 15, and 19. To describe it, that means they're asking us to tell what is the value that I'm either increasing or decreasing by. Since it's an arithmetic sequence, I know it's going to be either increasing or decreasing. So in this case, I look at this and I think, okay, 11 minus 7, that's 4. So that means I have to add 4 to get from 7 to 11. Does that work? Yes. If I add 4 to 11, do I get 15? Absolutely. If I add 4 to 15, do I get 19? Absolutely. So I know that the description is that you add 4 to each term. Now the next 3 numbers in the sequence is what they ask us to find. So let's find those. 19 plus 4, so that's going to be 23. 23 plus 4, that's going to be 27. And 27 plus 4, that's going to be 31. All right, so we've completed this sequence. We know it goes on forevermore, but we were just asked for the next 3 terms. Okay, let's take a look at another example. At this point, if you feel comfortable enough to pause and try to figure out what the pattern is, and then get the next 3 terms before I give you the answer, that would be a great idea. So here they ask you again, describe the relationship between the terms in this arithmetic sequence. We know it is 0.1, followed by 0.5, followed by 0.9, followed by 1.3. Okay, so they're asking me to find the pattern that exists between these numbers. So I look at 0.5 and 0.1. 0.5 minus 0.1, that's 0.4. So that means I'm adding 0.4 each time to get from one number to the next. And indeed, 0.9 plus 0.4 is 1.3. So we know that the description of the pattern that exists is that we are adding 0.4 to each term to get the next term. Now again, we need to find the next 3 terms in this sequence. So let's go ahead and do that. 1.3 plus 0.4, that's going to be 1.7. 1.7 plus 0.4 is going to be 2.1, and 2.1 plus 0.4 is going to be 2.5. All right, let's go on to the next example. Now, not all sequences are just going to be listed for you. Sometimes you're going to have to read the problem and figure out what the sequence is, and in this particular case, we're also going to need to figure out an algebraic expression that would take us from one term to the next. So let's start to break this down. Mehmet started a new exercise routine. The first day, he did 2 sit-ups. Each day after that, he did 2 more sit-ups than the previous day. If he continues this pattern, what algebraic expression can be used to help him find the total number of sit-ups on the 10th day? All right, so I have my setup, and then they also want me to figure out how many sit-ups he actually did on that 10th day. So I have a sequence that is determined by the number of days that have passed. So I'm actually going to write this one out in a table. Anytime I'm asked to come up with an algebraic expression, I know I'm going to need to set it up with a table. Okay, so if I think of D as day, because I'm going to need a variable for an algebraic expression, all right, D is my day, and then let's say that this here is my number of sit-ups. Okay, so I know that he started the first day, so that would be day 1. He did 2 sit-ups. The next day, he did 2 more sit-ups. The next day, he did 2 more sit-ups. The next day, he did 2 more sit-ups. Now, I could keep going and doing this until I get to the 10th day. That's going to be pretty simple to do. But what if they asked us about the 20th day, or the 30th day, or even the 159th day? We want a formula so that we could easily figure out on any number of days, it's called the days D, how many sit-ups he's done. Well, I look at the numbers in this pattern. I do notice that it is an arithmetic pattern. All right, so I do notice that I increase by 2. This here is my sequence, because those are my terms. And then these numbers here, they just tell me what place in the sequence I am. So here I'm at my first place, second place, third place, and so on and so forth. So I know I'm adding 2 each time. So I know the pattern is add 2 each time I increase by 1 in the pattern. So I'm adding by groups of 2. I also notice that if I take the number of the term, so the place of the term, the position of the term, and multiply it by 2, I actually get the term itself. It's true for 2 times 2, 3 times 2, and 4 times 2. So that means that on the D day, okay, so day number D, I'm just going to multiply that by 2, and my algebraic expression would be 2D, which would get us to any number of days that I wanted. So they're saying on the 10th day, well, if my algebraic expression is 2D equals the total number of sit-ups, on the 10th day, that's going to be 2 times 10. We know he's going to do 20 sit-ups. And I can use this for any amount of days. 160 days, I would just multiply that by 2 to get 320 sit-ups. All right, so that concludes our lesson. Here's your problem of the day for tomorrow. So the first 2 problems, you're just going to describe the pattern. The next 2 problems, you're actually going to write the next 3 terms. I mean, you're obviously going to need to figure out what the pattern is, but you don't need to describe it in words. All right, so you have 4 problems for you to do before I see you in class tomorrow, and have a great night.